Good morning. Let's go over the linear programming problem that we did on Friday. So this is a scenario of a business person printing brochures and flyers to advertise sale items. Hold on 1 second, yes. And they want to know what would be the best way to minimize the cost. So we're going to look at each different part of this equation. So remember, the objective function is always involving some kind of money. Usually, we will have one that doesn't involve money. So the objective function, if it involves money, we're going to say each brochure costs 8 cents to print and each flyer costs 4 cents to print. So let's make our objective function. So we always write f of some kind of two-variable system. Okay, so since we're talking about brochures and flyers, let's make it a B and an F. And then we're going to, hold on, and then we're going to go and describe it. So if a brochure costs 8 cents to print and a flyer costs 4 cents, then we're going to say 0.08 for the brochure plus 0.04 for the flyer. That describes your cost of how much it costs. So I'm going to cross these out because we're done with those. Okay. Now our constraints are basically what our restrictions are. So our constraints are going to be, we've got pages, and that's about it, really, the number of pages. So let's go circle everything about pages. A brochure requires 3 pages and a flyer requires 2 pages. And she wants to use not more than 600 pages. So let's say we're going to say for all the pages we're going to use, we're going to do a total. All right, some of your constraints involve totals. So we're going to say 3 pages for a brochure plus 2 pages for a flyer is going to be less than or equal to 600, because we only have 600 pages we want to use. So we're done with that one. Let's go and cross that out. I'm going to erase it and then cross it out. All right, and she doesn't want to use more than 600. Now, she needs at least 50 brochures. How would you write at least 50 brochures? So brochures have to be greater than or equal to 50. And then she wants 150 flyers. So flyers also have to be greater than or equal to 150. All right, and we're also talking about things. So since we're talking about things, you could say, well, B has to be greater than or equal to 0, obviously, and F is also greater than or equal to 0, because these are things you can count. So we don't go into negative numbers. All right, so let's take this information and we're going to graph our constraints. So here's one thing you need to remember. We do not graph our objective function. Do not graph. Okay, not this. We're going to use this later. But we are going to graph all of our constraints. So go on graph paper. I have my graph paper ready to go. I'm counting by 25s. So I'm going to go ahead and graph all of my constraints right now. So I'm going to pause the video. You should pause the video too and graph your constraints. Okay, so I have my 5 different constraints here. And actually the ones about the zeros don't really matter, because if they're going to be greater than or equal to 50, they're also going to be greater than or equal to 0. But sometimes you're going to want less than a big number and greater than, you have to remember that they're greater than or equal to 0. All right, so let's solve this for our second variable. See, this could be your x variable and this could be your y variable if you think of it that way. I just go in alphabetical order because x and y is alphabetical. All right, so I'm going to solve for our f. 2f is less than or equal to negative 3b plus 600. Divide everybody by 2, and you're going to have f is less than or equal to negative 3/2 b plus 300. So let's graph that. There's your 300. That's your y-intercept. I'm going to count negative 3/2 for my slope. So you're just going to go down 3 and over 2. You can do the same ratio. All right, down 3 and over 2, down 3 and over 2. All right, there we go. Or you could have graphed it with intercepts, right? 3b is equal to 600. so that you know your B or your X is 200 if you solved it for B, or 2F is equal to 600, so you know your y-intercept is going to be 300. All right, you have to graph very precisely, so use a very good straight line, possibly a ruler to find that. Mine's actually not as good as it should be. I'm going to try to move it a little bit. There we go. Okay, so now let's graph our other constraints. So I'm not going to go and fill these inequalities in yet until I get a couple more things. B is greater than or equal to 50. So if B is greater than, or remember B is your X, okay, X variable. So greater than or equal to 50 goes up like this. Ooh, I'm going to use my straight line thing here and do it because that's not very good. And it really does have to be precise. Greater than or equal to 50 goes like that. And greater than or equal, and then F being greater than or equal to 150. Now remember, F represents your Y variable. So that's going to be a horizontal line. So let's go and turn it into a line here. So greater than or equal to 150 is going to go here. So let's shade, because we don't really know where we're shading. I'm going to go and change my pen to look like a highlighter. So I've got, all right, less than or equal to that diagonal line. So that's going to go down here. And then it's also going to be greater than or equal to 50 on the X. So it's going to be on this side here. You've got this little region going on right now. Okay. And then you've got, okay, so it's greater than or equal to 50, which is your vertical line, and less than or equal to, oh, I did the wrong region. Hold on. All right, we don't care about this right here. So, nope, less than or equal to is going to go there. And it would be down here, would be part of our region that we're filling in. Okay, less than the diagonal and greater than that vertical. Now we're going to go and shade the horizontal. So the horizontal is greater than or equal to 150. So it's going to be just above the horizontal line. So we're going to just be shading right here. So wherever it turned green is where our constraints are going to all meet. So now we're going to label those. Go ahead and label. All right, I'm going to change my pen back. So it looks like this is at 50 and 150 right here. And then this next one, so that's your first one, you got this one here and you got this one here. You're labeling your vertices. Then you've got 100 and 150, that's your second point right here. And then at the very top, you've got 50 and 225. Okay, so now we're going to go back to our, I'm going to add another page here real quick, and I'm going to plug that into my objective function. So go back to your objective function. So I wrote my objective function out again. So I'm going to plug in each of my vertices. So the first one I'm going to plug in is going to be f of, I'm going to do 50 and 225. 50 and 225. So you plug all that in, 0.08 times 50 plus 0.04 times 225, and you're going to get a number out, and this is going to be a cost function. So go ahead and calculate that. All right, and that comes out to be $13 if you calculate it. All right, let's go back and plug in our other one. I'm going to go back and look. Okay, so the bottom one is 50 and 150. We're just plugging that back into our objective function. We're going to put a 50 in for the B and a 150 for the F. Go ahead and calculate that up. Okay, and that comes out to be $10. And then when you go and plug in the next one, the next point was 100 and 150. Plug that in. And you should get $14. So our most cost-effective combination of flyers and brochures would be if we were to get 50 brochures and 150 flyers. That would be the minimum that we would spend, and we would still have all of those objectives met. Okay, that's it for linear programming review.